Hello, everyone. So I'm actually this is collaboration work with the team in Oyster, and the first author in Katia is not here. The reason is she betrayed us. She went to another conference, so I need to take the responsibility now. Okay, so it's about emergence. And so usually we can observe some microphenomena, and we also observe macrophenomena, and we always try to find the relationship between them. So, for example, when we study emergence, we try our best to know how the individual level can together have a macro collective level behavior. But for simple system, we probably easy to locate the level, for example, the collective level and the agent level as individual level. But it's really not the usual case if we have a much more complicated system. And for example, the brain. For example, in neuroscience, we have lots of measures for across different spatial and temporal scale. We have single cell recording, and then we have like a local field potential, and we measure fMRI, we measure EEG signal. They all have totally different spatial and temporal resolution. So how can we really understand the brain based on those measure from different level? So every neuroscientist is always trying to use their tool and try to understand how to interpret. We have a collective behavior from the brain as our individual action. But however, the reality is we don't really work together. We just take our measure and then try our best to create our own ontology, to create our own description, and then explain the behavior without mentioning any others. People's tool, skill, anything. So is it dangerous or is it okay? We don't know. So this study is trying to a little bit reveal what happened if we do this. So this is a very simple toy model simulation. And so we, in our simulation, we kind of define three levels. One is collective level behavior, and one is individual level, and one is the neuron level. So, and we put the selection pressure on the collective behavior, so it can evolve, push it to involve collective collaboration, and see what's going on down to the more micro scale level. Okay, so the task is very, very easy. We call it group formation task. So we have three agents. They need to step together within the radius, and when they step together and explore the environment, we consider it's a successful action, collective action. So the fitness function is they need to stay together and also try not to cover the previous explored area, and so this will give them reward. And so for the neuron level to individual levels, this is very simple CTRNN networks. And we have 4 sensory inputs responsible for different visual 90-degree visual field. And the 4 sensory input then activate internal 4 neurons and drive the direction of the agent, turn left or turn right. So based on this very simple construction, we can so this is a demonstration of this task. So this is just for 100 the 100 generations, and you can see there's a homeless individual cannot stay with the group, and so it's not very good from this 100 generation. But anyway, so based on this simple model, we can actually quite well define the collective behavior. So it's we can take the center of mass as the collective measure, and also agents position as individual levels measure, and also neural activation as the neural level measure. Okay. And we run evolutionary reason and triplet. They evolved together and 5,000 generation to 20 simulation run. But this is the intermediate result. For example, you can see the 3 agents. They 3 agents, they can stack quite well together, but sometimes they still cannot stay in the same radius, but they can come back quickly. And so they performance improve a little bit. And the next one is the final generation, one of the example final generation. So they actually develop a very, very good strategy. So it's a leader and follower strategy, and then one can take care of the other two, and the other two just keep eye on each other and follow it. So they can travel very long distance and get high reward together. Yeah. So from here, we can know they already developed the collective behavior. And so next, we want to go into the measure of emergence, okay, across levels. So the current study, we take Ferrando Rose information causal emergence measure. And this measure is quite synergy-based framework, and in this framework, they propose formalize three concepts about emergence. One is causal emergence, and one is causal decoupling. Causal decoupling means macro and micro, they cannot predict each other's feature, and also downward causation, but this is weak version, so it's not real downward causation, but it means if we have a partial observation of the system, we can only see some individual, and the prediction from the individual to other individual is weaker than the macro variable. So, but anyway, so why it's synergy based is important, because synergy, information synergy, you can consider it's the information from the joint the interaction between elements, and so it's pure synergy based. So from this framework, we can try to measure the emergence, quantify the emergence cross level, and they also propose the practical criterion, and so we can measure it as a sufficient condition to say whether this system have a causal emergence, downward causation, or causal decoupling. Okay, so now we can, because we already have all the variable, and we can compare the take one as a macro and take the other one as micro. So we have a 3 comparison we can see, and then there are 2 important things we want to see. One is performance and emergence relationship, and the other is how the evolution changed the emergence. Okay. So the first result is for causal emergence. We can see it's only the collective level to the neuron level, and also individual level to the neuron level. They show positive value, and the positive value can sufficient say they have we observe the causal emergence. But actually for the collective level to individual level, it's actually negative. So which means if your measure is, you pick a measure in its individual level, then you will have totally different result from if you're measured from the neural level. And this also show in other concept in emergence. So okay, so we don't see any downward causation in our system, and so the downward causation need to be this delta need to be positive, but it's negative. But still, you can see the collective to individual level, they have more negative value here. It's show very different relationship between these 2 level other than the other 2 comparison. And also we can see causal decoupling here, and so this need to be 0 and phi need to be positive. We can say there are causal decoupling. So this means neuron level is actually decoupled from the individual and collective level, but we cannot see decoupling from the individual to collective level as previous data showed. And if we see the performance, the correlation between performance and causal emergence, it's much more clear that we have a performance very good correlation. However, this one is totally different from the other one. So for neuron level, the causal emergence increase when your collective performance increase. But if you select the measure from the behavior level, it's actually decrease. Okay. If we take the evolutionary trend, you can also see the two measures separate from the two neuron levels separate from individual and collective level for all the evolution generation. So you can see the for causal emergence, if you involve neuron level, then it's statically increased. But if you examine individual and collective level, actually the emergence decrease. It's the same thing in the downward correlation and also causal decoupling. So very short summary. Somehow we can, we can see if we cross this boundary, the neural boundary, the neural activity is the process of neural activity is actually when we measure it, it's decoupled from individual and decoupled from the collective level. But if you really take the measure from individual level, then it's actually not totally no emergence can be found. And so a very important implication here is the relationship cross level is very scale dependent, and second is most likely is task dependent. Maybe I will explain if I have time. Also, it's definitely measure dependent because this emergence measure is purely defined by the information synergy. So yeah, and so the last slide. There are many open questions we want to see, but then maybe we can summarize into a simple question. Can we predict degree of emergence cross level and scale? And from our study, it seems hard. And we only have 3 levels. We already show very different trend if we select different measure from different level, and we don't know how micro most like as brain complex system those multiple scale how will it be? And actually, there's a good poster. I recommend. In this poster, they also try to examine some similar concept, and they actually show multiple peak at different scale. So it's in general, it's very hard to predict how the relationship between levels. And second, in this task, we feel they have emergent behavior because they work together. But working together actually is not synergy. Information synergetic behavior is more like a synchrony, but synchrony is more related to redundancy. So whether the emergence measure, how can we incorporate them synergy and redundancy together? I think this is a very difficult but important question in the future study. And maybe most important empirical implication is when we, for example, study neuroscience and we pick all different majors and we just do our work, and how is this related to other people? And if you have a causal decoupling, actually your work is totally not and this is the final one. So yeah, thanks for my collaborator. So Claudia did most of the work, and Fernando did most of programming work, and Yi-Shan helped some analysis. And then you may think, what did I do? I don't know. It's a good scientific question. And final one, Katia is not here, so she say it's very sad not to be here, but she is looking for next position, so please hire her. Yeah, thank you for your attention.